minute to do, but if you want to hand it in, I'll take it. Just give it to me at the end of the period. So now, how do I identify that it's a proportion? It's a percentage. Somebody gives me a percentage of something. Does it have any standard deviations in it at all that I could use a z-score or a t-score formula? No standard deviations are given. All that's given is usually my n and sometimes my x or a percentage, my p hat. So that's how you're going to be able to tell when you take this test. If I jumbled them all together, you'd have to decipher which one to use, and usually I'll do all of the t-tests and then I'll do all of the p. But once we decipher what's going on, the rest of this works the same. Your sketch is the same. Your label, the reject region, is the same. Your p-vals, you can find and test with your p-vals. You can test with your reject regions. The only thing that's different is actually the t-test, this test statistic, we call this. This is the only difference that you really are going to notice. This is your mean. These are the means, sample standard deviation, and this is your, it's a z-score, but we use p hat minus p over pq divided by n. Mercedes, I'm collecting the work that you guys did yesterday, so if you could get it out, I'm going to collect. You weren't here yesterday? Okay. All right, so this is the major difference in the work part of it. This is how we decipher which one we're using. This is what we do to figure out the work. Yeah, you have the calculator steps for this one. T-test, sorry. And this one proportion, z-test. Okay, you can use your calculator. It's fine with me. I still want the sketches. I still want the reject areas labeled. I need all of that stuff. Are we good with this part? How to tell the difference? Okay. I'm going to wait till you guys finish copying that. Let's go to, I think some of you forgot on the t-test. What table do I use for a t-test? Table 5. It's different than my z. This is table 4. This is my z. So if that was a little bit confusing, this one I can't use inverse norm on. This one I can use inverse norm on. The other one you can use inverse t, but it's so much easier to do the table. The table gives you a one-tail and a two-tail row across the top. So use the table versus using the inverse t. Okay, let's jump to 37 since you did these guys last night. 37 says a fitness magazine advertises the monthly cost of joining the club is $25. Kayla, I collected the work from yesterday. So if you want to get it out, I'll take it. So is $25. There's your claim. Go to the back side of it. Do you have enough evidence to reject the advertisement's claim? So reject tells me I should be HO. Isn't an equal sign HO? Isn't this the advertisement's claim? So you know you're on the right track. Now sometimes, don't forget, they give you your sample first. Sometimes they give you your sample second. It depends which way they give it to you. Okay. All right. So we say our claim, HO. Our alternate is not equal to. This is my tail, my two tail. So I draw a sketch. I label my shaded areas, reject H0. I label my open area, fail to reject H0. Where do these numbers come from, these critical values? Where do they come from? The table 5. So I need to know how many is in my sample. 18. My degrees of freedom is 17. Which one do I follow? One tail or two tail? Two tail. 0.10 level of significance, degrees of freedom, and I get one positive value. I know my chart, my graph is symmetric, my chart is symmetric, so I put the negative on the other side. Those are my critical values. That's where I'm going to test against. My test statistic says this. Take my sample mean minus my population mean divided by my sample standard deviation divided by the square root of how many are in my sample. I get my test statistic. Then I need to see, where does this fit? This fits right here. It falls in my fail to reject H0 zone. This is my decision. That's my decision. Then you go to the interpretation. And I want to see it like that. This time, if it's not there, you don't get any partial credit for your interpretation. I want to see it written out the right way. If you test with the p-val, and I'm fine with you testing with the p-val, if I don't ask you for one or the other, you're going to test with your p-val against your level of significance. How do I find my p-val for a t-test? I can't find it on the table because all the table does is give me those little values. It doesn't give me area. In the calculator, you're going to have to use your calculator for this. You're going to have to go to stat, test, and come down and plug this in. Now here we have another problem. We need an x value. Did they give us an x value? Yep. Oh, no, this is my proportion. Sorry, I'm on the wrong one. T-test, sorry. So, where does this come from, the first one? The U. Your claim, that's your population. Your claim is made about the population. You test with your sample. You put your sample information in here. If I ask you for the p-value, you're going to have to use your calculators for this. Plug in your n. Follow your tail. It's a not equal, so we're okay with this. Now, there's your test statistic. And I'm fine if you want to bypass this and tell me you used your calculator. There's your p-val. Do I have to multiply this by 2? No, your calculator already did this because you told it was a two-tailed test. So whatever the p-value is whatever p-value you use. And it just goes through and repeats what some of your information was. So I'm at 0.1190. I'm testing 0.1190 against my level of significance. Fill it with zeros, and that's greater than, it's the same decision. Can everybody do this? Yep. Let's hit a little bit more of these p-values reviews here. Okay, so take a look at number 29. Number 29 wants us to find our cutoff values for a two-tailed test for a t. How am I going to find my cutoff values? Table 5. What am I going to look up? Degrees of freedom 19. Two-tailed, follow the two-tailed, follow 0.05. Look it up in your table. Make sure you can do this. Go to table 5. It's A18. Probably can see through my arm. No way to hide it. Should those values be the same or should they be different? They should be the same. Should they both be positive? No. The left side should be negative. So do we get these values from your table 5? Make sure. Do not call me over tomorrow saying I don't know what to do. Okay. Left tail test. Degrees of freedom 14. My level of significance 0.005. Okay. Is 0.005 on your table? Yeah. Do you look under one-tailed or two-tailed? One-tailed. So when I get this, it gives me a positive 2.977. It's my left tailed. I make it a negative. Good? Okay. You guys try number 33. Try number 33. Okay, so we have just a problem, no word problem here. So our claim is our HA, our tail test, right tail test. Everybody got the right critical value from the table 5? Anybody not get that critical value? It's critical that you get that critical value. That's your cutoff. Okay, so now take your equation, your formula, or your calculator. Either one is fine with me. If you use your calculator, just tell me calc, because it's always a little bit different. If you use your calculator, it just does the rounding a little bit different than we do. Find your t, find your p-value from your calculator, test your level of significance, and you'll get the same answer in both places. There is enough evidence since our claim, since we're rejecting our HO, we don't want this guy, we kind of want this. So we're going to support what they're saying. Since our claim is an HA, we're going to use the word support. There's enough evidence of the level of significance of 0.005 to support the claim that the mean is greater than 12,700. Everybody can do this?
I'm going to keep messing up on this whether or not to do the T formula or the Z formula, or not T formula, but like to do the TP or Z.
So what tells us this is a T is this right here. Sample standard deviation. Right? If I know my population standard deviation, then I'm a Z test. If I don't know my population and I only know my sample, then I'm a T test. If they don't even give me a standard deviation and they give me a proportion or a percentage, then I'm a P, proportion. So, and they give you no standard deviation there. Because even if you go to your calculator and you look at it, there's no standard deviation that if you went to the wrong one, you'd put the wrong one in. What's nice about this is also, if you forget, go to your calculator. Do you use the calculator? Okay, but watch. This is what's helpful in your calculator. If I'm here at a Z-test, what standard deviation are they asking me for? Population standard deviation. If this is my problem, do I have a population standard deviation in here? No. I say, whoops, I think I got the wrong test. Let me go back. Let me look at my stats. My stats. Again, let me see what my Z-test has. My T-test, sorry, my T-test. When I get here, they want my sample standard deviation. So because I'm given my sample, it's going to fit right here. So the calculator is a good guideline for this. And if you do the P, it doesn't ask you for a standard deviation at all. It just asks you for a proportion. X over N is your proportion. So it kind of does make sense that it all fits in together. You just got to let it make sense. And, you know, I know that you don't always use the formula, the calculators, but then you're going to have to remember that the T-test uses the sample standard deviation. The Z-test uses the population one. And the P goes back to using Z.
So for the T-test, when you're finding the critical value, that's the only formula that you have to use when you're looking for, right?
You're good for your critical values, T-test, table 5. And tomorrow I'm going to give you table 4 and table 5. And the table 5 says T distribution on it. So when you're doing a T-test, make sure you're using the T distribution table. That's what you need to find this value right here. Right here.
Doing a Z-test, we just use the A to find the value of the right?
If you're using the proportion one?
No, like if you're just doing a Z-test,
Table 4.
your level of significance, and
Yeah. Inverse norm.
And then that's how you find it.
This has one. This has an inverse T out here. Maybe. This has an inverse T. Again, you're going to have to worry about where you are because you're going to have to tell it you're on the right-hand side. I'm not real fond of having to do it this way because I think it's confusing. This one you have to place in the right spot. I'm pretty sure you have to place this in the right spot. minus. You have to find your degrees of freedom. What was your n? 21 was your n? 20. And then you paste. This will give you, oops, something happened. Something happened. A little tricky thing today. My calculator doesn't always work well up here for some reason. Maybe it's me. So I should get this number over here. See it? You can use your inverse t, but you're going to have to tell it. I don't think it might give you the negative. I'm not sure if we put it in the other way. I put it in without the 1 minus. Yeah, it'll give you the negative without the 1 minus. So you can use your inverse t, but what you have to remember on inverse t is the 2 tails. You have to divide by 2, just like you do the inverse norm. You can do that if you rather use that than the table. I just think the table is easier because the table actually tells you 1 tail, 2 tail. It's like thoughtless. You just read you follow your row, your column, you got your critical value. You really can't go wrong with your table. Sometimes with the 2 tails we forget to say divide by 2. It won't happen on your table because it says 2 tails. Okay? Alright, so then you guys did 37. Alright, so take a look at 41. Everybody try 41. What are they exactly asking you for? What is the directions asking you for? Determine if you could use a normal standard distribution. What are they asking you for? The lesson. But you have to determine it yourself. What do you have to do? Yep. N times p greater than or equal to 5, n times q greater than or equal to 5. And then if so, then you can do whatever you need to do to it. But if you have to determine, you have to do the test. The other one has to tell us either n is greater than or equal to 30, or it approximates a normal curve. This one, we have to decide ourselves. So if we're going to test, we have to do an n times p and an n times q. So we take your p, we find your q. Your sample is 40. This one's greater than 6. If your smaller one is greater than 5, shouldn't your larger one be greater than 5, right? So test your smaller one. So this tells us, did you decide if this approximates a normal distribution? It does. So then I can go and do whatever I need to do. Now, yeah. How do I know what to use on this? It's giving you a p-hat. Where else do you see a p-hat? Proportions. It's giving you your claim with the p.
I'm confused.
The hat? It's way up there. When I do this, I use the math type thing, and for some odd reason, the little hat comes so far above the thing, and it's so light, I don't know how else to get that down there. Yeah. On the old way I did it, I just drew it in. But, so now, we have a claim. This claim is our HO. So therefore, we know we have a 2-tailed test. Okay, we're back to your z-scores. How do I get this critical value? Where did this come from? So what did you look up? So what did you look up to get this, David? Which one?
It's either means one is not T,
So table 4, and how would you find this how would you get this number? We don't know this number. How did you get this number? DC, okay. But we got a little bit of a problem here. So what is your ZC going to say for 0.05? Does it say this number? See, that table 4 gives you a little thing on the bottom. Dave is right. But what's the problem here? What did your table 4 in the bottom say for 0.05?
Or for 0.05?
Mm-hmm. They don't give it to you. So where am I going to find this?
0.95.
Inverse norm. What am I going to have to do to inverse norm? Divide it by 2. Why? Because it's 2 tails. Come on, this should be flying out of your mouth right now. Divide by 2. I need to be able to divide this by 2. Well, you can find it in your inverse norm for some odd reason. My inverse norm is not. Oh, I missed the point. It's just not cooperative today. Some days it works really, really well. Okay, if you don't divide it by 2, you're not going to be able to share that piece of 0.05. It's got to be shared for 2 tails. Now, when you do this, look up here for a second. You're dividing this in half to share this. At the end, if you're doing a p-val test, you're going to multiply that area by 2. It has to go together. If you divide this, then you multiply your other area by 2 if you're doing a p-val test. Okay? If you use your calculator handles it for you. You tell it what test you are. So your calculator handles that part for you. Okay? Are there any questions to do this? We just switched modes. We just went from your t-test to your P. Everybody saw that. Okay? So here's another little problem. I want to put this in my calculator, other than my calculator not being cooperative today. I've got a little bit of a problem. I go to put this in. I put in my P from my population. That works for me. I go to put my P hat in, but I don't have a place for P hat. I have a place for X and N. Well, I know my N is 40. Okay, so maybe I have to put my X in first. So, I don't know what my X is. What do I do? Take 0.09 and multiply it by 40. I want 9% of that 40. Make sure you use a decimal point when you multiply. So what is 0.09 times 40? Oh, but I can't put a partial person in there. So I have to round it to 4. You just use your rounding rules with this. Again, I follow my tail. I'm an equal sign, and I calculate. On your Z, you get your Z test statistic, which is covered by my calculator. You get your p-value. This is your p-value. This is your p-hat. A little bit off than this one, because we had to round your x value. And that's okay, because you're going to tell me calculator. And I'm going to know that you didn't use your formula, you rounded. So this, in this case, this one's not going to match your 0.09 right here. Right, but this is my p-value if I want my p-value. How else could I find my p-value for this? What else could I do to get my p-val if I don't want to use the calculator? No, there's no formula. Table. What am I going to look up in my table? Look at my z-score. Good. And what am I going to do to that area? Multiply it by 2 to get your p-val. So if I ask you for a p-val test, make sure you can do that if you're not using your calculator. And your calculator is fine. Make sure you tell me calculator. Because you can see that the calculator is a little different than the one we do with the formula. Because we're still using 0.09. Your calculator is actually taking 10%. So there's a little bit of a difference. Speak now if you're not catching this. And let's jump to 45, the one you did for homework. So a polling agency reports that over 60%. What does over mean? Greater than. More than 60% of U.S. adults feel that the federal government bank bailouts were bad for the U.S. In a random sample of 298 U.S. adults, 167 said that they felt it was bad for the U.S. In this case, they didn't give you a p-hat. They gave you an x value. This is your sample. And they gave you an n value. If you're using your formula for p-hat, you have to find your p-hat. If you're using your calculator, life is good. There's your x, there's your n. So claim happens to be the HA, tail happens to be the HA. Okay. This one again is really off either, and sometimes if you're the one that's running this, if you're that far off, you might want to do another sample, and you might want to say, yeah, this was really that different than what they said it would be. So, no, I'm not going to support what they say. Maybe there was a higher percentage that said this. Maybe there was a lower percentage. Maybe I'll just do another sample to make sure I'm on target. So p-val, remember with your p-val, you're actually looking for the area to the right, so you're going to have to subtract your area from 1. If you use your calculator, it does it for you. Everybody good with this? Any questions? I know some of you are catching this. I'm sorry to